we already know that there is at least one real number called square root of 2 that is not a rational number. So we know that the set of real numbers is strictly larger than the set of rational numbers. And it is possible to build the real numbers from the rational numbers. But that is beyond the scope of this course. And instead, what we're going to do is that we're going to take the real numbers as a set together with some rules, some statements that we take as true. We don't prove them. They're called axioms. It's something that we just take it as true. And that set together with all those axioms or rules is what we are going to call the real numbers. So I'm going to group them depending on some of the main ideas behind those rules, and then later in a future video I'm going to put everything together. So the first one are field or algebraic axioms, and they're actually quite simple. I'm sure you are familiar with them. The first one is what we call closure. It just tells me that if I have two real numbers and I add them together, I get a real number. And if I have two real numbers and I multiply them together, I get a real number. So the real numbers are closed under addition and closed under multiplication. Then we have commutativity for both addition and multiplication. So we know that A plus B is equal to B plus A, or that A times B is equal to B times A. Then we have associativity. This is the one that allows me to group things. So if I have like A plus B plus C is the same thing as A plus B plus C, and the same thing about the product. Then we have an additive identity, which is the 0. So any number plus 0 is just itself. And we have a multiplicative identity, which is number 1. Like any number, A times 1 is going to be equal to A itself. And then we have the existence of an additive inverse. So it's like if I add the additive inverse to the number, I end up with 0. So A plus negative A is 0. And if I multiply by the multiplicative inverse, so for example, in this case, have that A times 1 over A, or A inverse, is equal to 1. And then the last property in this list is going to relate the addition and the multiplication. So it's telling me that if I have real numbers A, B, and C, A times B plus C in parentheses, this is equal to A times B plus A times C. And this is, as I said, distributivity of multiplication over addition. All these properties, I'm sure you know them extremely well, you're very familiar with, and these are the rules of the game. This is what we are allowed to assume as the truth for the real numbers, together with some other axioms that we're going to see later. And now I want to show you that there's some elementary consequences of these field axioms. For example, that 0 and 1 are unique, that the additive inverse and the multiplicative inverse of non-zero elements are unique, that any number multiplied by 0 is equal to 0. For example, that if x times y is equal to 0, that means that x is equal to 0, or that y is equal to 0. All these things look obvious to you, but they need to be proven from the axioms that I just said. This list is what you're allowed to take as given to you as the truth. And this one, we need to provide a proof. So I'm going to prove 3. I'm going to prove that any real number multiplied by 0 is 0. And a bit of a warning. Proving something that is obvious is very, very hard, because your brain is saying, oh, but it's obvious, why do I need to prove it? But we do need to prove it. So let's take a look at 3. So the proof is quite simple. I just have it here. We're going to start again. We have to prove that for every real number x, x times 0 is equal to 0. So we start by fixing x, which is a real number. And then, well, x times 0 is equal to x times 0 plus 0, because 0 is the additive identity. I haven't changed anything. Now, I can rewrite 0 as something plus is additive inverse. So something plus minus that thing. So I'm going to replace 0 with x times 0 plus negative x times 0. And now I'm going to use associativity to regroup things a little bit. So I'm going to have that in parentheses, look at the yellow parentheses, we have that x times 0 plus x times 0, all of it together, plus negative x times 0. But look, we have x times 0 plus x times 0. So we can take x as a common factor. We can use distributivity here to end up with x times 0 plus 0 plus negative x times 0. But then 0 plus 0 is 0 because 0 is the additive identity. Anything plus 0 is the thing itself. So 0 plus 0 is 0. So we have that x times 0 plus the additive inverse of x times 0. Well, that means that x times 0 plus negative x times 0 is 0. And that completes this proof. As you see, the proof is not very complicated. You just have to carefully follow step by step and making sure that you justify it by using all these rules that I mentioned before. And I'm going to leave it as an exercise for you to prove all these other properties. Okay, now that we have that, let's take a look at the ordering axioms. So these ones are the ones that kind of give us the real line, and that gives us an idea that 1 comes after 2, and I don't know, 2.1 comes after 2.05, and so on. So first of all, we have that given two real numbers a and b, only one of these can happen. That either a is less than b, or a is equal to b, or a is greater than b. We can only have one of those three happening. They cannot happen all at once. We also know that if a is less than b and b is less than c, then a is less than c. That's what we call transitivity. And if we know that a is less than b, then a plus c is less than b plus c. And finally, if I know that a is less than b, I know that c is positive, then a times c is less than b times c. Okay, very good. So we have all these things that we're allowed to assume. They're just given to us. And with this, we can think about other things. For example, we have the idea of less than or equal to. How does it fit into this picture? Well, x less than or equal to y means that either x is less than y or x is equal to y, but you know that you cannot have both of them at the same time. And we have some very important consequences that I'm going to write here. For example, that if x is less than y, this is the same as y minus x is positive, or if x is positive, well, this is equivalent to negative x be negative. That if the product of x and y is positive, that is equivalent to that either both x and y are positive or that both x and y are negative. So I invite you to pause the video, take a look at all these properties, and try to think of how you could prove some of them. Pick the one that really speaks to you and try to write down a proof.